Number 15, we need to identify this transformation. If we look at number 15, it looks like its orientation has changed. So it doesn't look like it's just a straight up translation. It's not a reflection. So what kind of rotation? Oh, there, it gave it away. What kind of rotation is this? How many degrees did we go? It is a rotation. How many degrees? Number 16, are these congruent, similar, or neither? I can see that from here to here is 2.5. I can see from here to here is 2. I have the same measurement from here. That's 2. Up here is 2. And from up here to here is 2. Let's look at this one. This is also, this is only 2. So we got some problems already. On this shape B, the base and the height, these are only 2, whereas this one's 2.5 and 2. So we got problems there. They're not even the same shape. One of them's wider on the bottom or on the top than it is on the bottom. Number 17. We need to find the missing angles. First off, we need to figure out what this one is, this question mark angle. I know that this plus this plus this is 180. 73 plus 85 plus x, we'll call that x, is 180. So figure out what we're missing to make 180. Then we also have a straight angle here. So a plus whatever we get for x, that also equals 180. So go ahead and solve this first, and then figure out what was missing to make a total of 180. Number 18, we have a pillow in the shape of a soccer ball, has a 12-inch diameter. So from here to here is 12 inches. How much foam stuffing is needed to fill the pillow? So we want to know the volume. And honestly, I don't even memorize the formula for the volume of a sphere. So let's go ahead and Google it. Volume, not letters. Volume of a sphere. 4/3 times pi times the radius to the third power. In fact, this is a calculator. It'll do it for us. What was our radius? Our radius is halfway across, so it's 6. Let's go back to that. Type in 6. There's volume. Next one. 19. Francis would like to mail a 27-inch pointer in this box, corner to corner. So from here to here. We want to know, is it going to fit? Well, let's figure that out. This is a lot like the question we had. This is our Pythagorean theorem. I think it was number 13 or 14. So we first got to figure out what this is, because then we have this blue triangle. So we have, let's figure out this side. We get a squared plus b squared equals c squared. We get 9 squared plus 24 squared is equal to that line there. I know that's the longest one because this is my right angle. That's my hypotenuse, c squared. So let's do a little calculator work. I know 9 times 9 is 81. 24 times 24, 576, plus 81. This is going to equal c squared. So we get 657 equals c squared. And then the last step for that is going to be the square root. Type it in a calculator, 657. We get 25, so that's 25.63 inches. Now we're going to use that with this 9 to figure out what's our total. So let's do it over here. We'll do 9 squared plus 25.63 squared. If you already know what that is, it's right here, 657, equals c squared. So 81 plus 657 we get c squared. So that's 738 is c squared. Square root. If this is bigger than 27, it's going to work. Square root is 738. It's 27.2 inches. So it's going to fit. that was a crazy question. I know that was probably super confusing. So the first thing we did is we looked at this blue triangle. This was our goal. We needed to solve the long side, the top of this blue triangle. In fact, let me see if I can get a better picture of it. There we go. So the first triangle we need to recognize is from here to here, here to here, here to here. But we can't solve that until we have this measurement. So we do this squared plus this squared to equal this squared. And then we can find out that this squared plus the number that we just figured out is going to equal this squared. Kind of a lot. That'll get better when I've actually taught you this stuff later on in the year.